Okay.
So, cool. And apparently the others aren't coming again. So, I'm assuming you did the prep work, right?
Looked at it. I didn't write it, but I looked at it.
You're looking at the prep?
What's that?
Did you just say that you're looking at the prep work, or
I looked at it um, at work last night.
okay?
At work, I
Um,
print it out and write it down. I looked at
yeah. Did you have any questions on it, or did it
it.
make
No,
sense?
it did make sense. What about you?
I felt really comfortable with it. Like, I'm ready for this quiz if you are.
Yeah.
All right. So start. So for number 3, the total area under the density curve must equal 1, right?
Yes.
Okay.
Under certain circumstances, density curve can drop below the x-axis as false.
Yeah. A normal density curve is symmetric. That's true. All right. Use the following image to answer questions 6 and 7. By which of the following elements of the figure represent the C-score of the image?
That would
Uh,
be,
C, right?
yeah,
Okay. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1?
B.
It's B?
Yeah, because it's if you want
Right.
what's greater than one,
Yeah.
that's B. Now,
Mm-hmm.
into the 6895 rule, what proportion of the data from a bell-shaped distribution will be within one standard deviation?
It's 68, right?
Did you
Hmm?
did you bookmark the applet?
I did not. I forgot to.
So
Uh,
it's a good idea to do because um, they said we're going to be using it a lot.
mm-hmm.
So,
Yeah, I couldn't find it. When I was doing it, I was at work on a different computer, so I didn't
all
save it
right,
to that one. It'd be weird.
so let me see what's the question. Um, what proportion values?
We're on 9, right? Or still 8?
Nine. So they
9K. For 8, I got 68. Um, Suppose random variable z has a standard normal distribution. Use a normal applet to answer this question. What proportion of the values of the random applet is between -1 and 1? Give your answer as decimal accurate to 3 decimal places. All right, so we do need the applet, which I just pulled up.
all right. So the 0.683 number 9 is 0.683 because they want three decimals.
It's 0.683.
Yeah. Well, 6827, but if you round it to three, you just round up.
How'd you get that?
Well, on the applet, um, it's got my z-scores is -1 and +1, and then
Mm-hmm.
when you shade in that middle area,
Yep, okay, I got it. Sorry, I was just a little slow on that one. Okay.
we're this together.
Yep. Suppose random variable z has a standard normal deviation. Use a normal applet to answer the question. What proportion of the value of the random variable is between -2 and 2? Give your answer in decimal form.
0.955.
Yep.
Negative.
And then again, but with -3 and 3. .997.
Yep. Look carefully at your answers. What do you observe? Values match the rule.
It's the values match the rule. All right. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population in the United States. A protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 66 grams per kilogram per day, and the population standard deviation is 0.07 grams per kilogram squared. He uses this information to answer questions 14 through 17. Do you have a question 17?
No.
I have 13 through 16. Okay. Just what proportion of the population has protein requirement that is less than 0.6 grams?
Okay, so let's see, we'll need a calculator. Okay. All right, so we'll take 0.6
Mhm.
0.6 and divide that by 0.07. That gives us 0.857.
0.857. All right.
Okay. So that's our z-score.
Okay.
That's not the proportion of the population. So now
Right.
z-score into our thing. Okay, what's it asking? What proportion of protein? Okay, left. And so we're going to want to shade to the left.
Mm-hmm.
So
Wait, what did we get for our z-score again?
negative 0.8571.
All right, and you said shade to the left of that, right? For some population requirement that is less than this. All right.
Okay, which is an area of 0.1957.
Which is 0.196. All right.
Are you following what I'm doing here and why I'm doing it?
Yeah. No, I got you.
So what I 196?
Sorry, what?
What did we say it was? 0.196?
Yeah. And for number 14, what proportion of the population have a protein requirement that is more than that? So we shade in the other two sides, right? 0.804.
Okay, what proportion of our protein is less than 70? Okay, so let's take 70. That's right. 0.7 minus 0.66 equals 5 by 0.07. Our z-score is 0.571.
0.571.
Yes.
And it says less than or more than? Less than. Okay. So less than 0.571. Minus
So 0.716.
Yeah, that's what I got. And then find the probability that a randomly selected person with a protein requirement that is between 0.6 and 0.7 grams of kilogram per day. And remember that to find the area between the two values, shade to the left of each z-score you calculate, then subtract the smaller from the larger. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values.
Well,
Okay.
take number 15 minus number 13.
Yes.
So 0.716.
Actually, no, it'd be 14 minus 15. Because it's between the two. So if it's 0.7 and below and 0.6 and below, they wouldn't have that overlapping difference.
Oh, okay. Wait. 14 minus 15? Would that be 0.088?
All right. All right. I think that's correct. The only one I'm hesitant on is number 16.
Okay, so let's run it through the output then.
Yeah. Protein requirements between 6.7. Okay, so with the hint it says shade to the left of each z-score. So only the right one is not shaded. And so that very first one is 0.716, and the second one, or sorry, second and the first is more than that. What was our z-score for 13 again?
Real quick. Okay, so 0.6 minus 0.66. So divided by 0.8571.
Okay, no, you're right. It is, it's 15 minus 13.
So
For following.
0.716 minus 0.196. So equals 0.52.
0.52? Yeah. Remember to put a 0 at the end of that because it's tricky. All right. I feel good. Do you want to turn this in?
Sure.
All right. Yay, 100%. I'm glad we looked over 16 again.
Yeah. Okay.
All right. Well, I will post our link for our video, and we did good today.
All right.
All right. I'll see you on Tuesday.
All right. Thanks. Have a
Okay,
good weekend.
bye.